Boolean arrays can be used to select elements from other arrays, data frames, and series. When used for selection, a Boolean array selects an element if the corresponding value is true and deselects an element when false. Pandas data frames and series use loc to perform Boolean selection. In NumPy arrays, a Boolean array is interpreted as a list of integers where true in position I indicates the value I is included in the list. Because NumPy interprets Boolean arrays as integers, it is necessary to use mp.ix when selecting in more than one dimension. The number of elements in a Boolean array used in selection must match the length of the dimension of the array or data frame being selected. Start by opening Lesson 16. Run the first cell to load the momentum data that we will use in this lesson. Boolean selection in data frames and series uses loc. Boolean selection is equivalent to first using the Boolean array to select elements from the index corresponding to values that are true, and then using this subset of the index to select the values from the data frame or series using loc. A key requirement of Boolean selection is that the number of elements in the Boolean array must exactly match the shape of the dimension used in the selection. The first task asks us to select rows where all returns are negative. We can find negative returns using less than 0. We then use axis equal 1 to find rows where all of the returns are negative. We can assign this to a variable to use in the selection. Use momentum.loc cell to select the rows where all returns are negative. Running this cell shows that all returns are negative. The next problem asks us to find the rows where at least half of the returns are negative. This is similar to the previous problem, except that we use mean axis 1 to get the frequency of negative. We then compare this frequency to 50% to define our selection. Again, we use loc to select the rows that are needed. Running the cell shows that most returns selected are negative, although there are clearly some positive returns as well. While I have assigned the Boolean array used in selection to a variable, this is not necessary. We can use mathematical operations and comparison in the loc command when selecting a subset of a data frame. The next problem looks at column selection. We are asked to select the columns with the smallest and the second smallest average return. We can use mean to compute the average returns. We can then use sort value to sort the means from smallest to largest. The first two rows in this series have the lowest returns. We can use Boolean selection, where we select columns with a mean less than the third sorted mean. Note that we must use a colon, the trivial slice, to select all rows. We could also directly select the columns using the labels in the mean vectors index. Since this is sorted, we need the first two labels. The next task increases the difficulty of creating the selection vector. We want the column with the most negative return on days where all returns across the 10 portfolios are negative. We can use all axis equal 1 to get the set of days where all returns are negative. We can then get the smallest return using momentum.min.min. The column with the smallest return has a minimum that matches this global minimum. If we run this cell, we can see this is MOM01. We can use the two Boolean arrays to select rows and columns that match these criteria. The next problem asks us to compute the correlation between the portfolios 1 and 10 when both returns are negative and when both returns are positive. We start with a selection statement that finds when both are negative. We must use ampersand here as the logical operator AND, since we are using two Boolean arrays. We can simultaneously use the Boolean arrays to select rows and a list of the column names to select the columns using loc. Finally, we can call core on this subset. Selecting the positive returns is identical, only using greater than. Again, we mix a Boolean array to select the rows with a list of column names to select the columns using loc. Running this cell shows the correlation is lower on positive return days than on negative return days. This is a stylized fact of equity returns. The remainder of the notebook looks at Boolean selection in NumPy arrays. Logical selection in NumPy arrays behaves identically to integer selection. The arrays are effectively converted to integers using np.where. This limits direct selection using Boolean arrays to a single axis, and np.ix is needed when selecting in more than one axis. Start by running this cell to generate some random integers in a repeatable way. Selecting columns is not very different than selecting in DataFrames, and we can use mean axis equals 0 and a comparison operator to generate the Boolean array. We use brackets to select in NumPy arrays. Selecting the rows is identical, only using axis equals 1. Running the cell shows that many rows have means above the expected value of 5.5. Naively extending the example to rows and columns produces an error. This happens since you cannot directly use Boolean selection in multiple dimensions. Instead, we need to use ix with the Boolean arrays. Where is a function that turns Boolean arrays into integer indices. First, we can look at the Boolean array. A set of integers is returned when we call where on this array. When calling where on a two-dimensional Boolean array, we get a set of two arrays. The first contains the rows that are true, and the second contains the columns. Let's split the tuple out into rows, which is in the first position, and calls, which is in the second. We can check this by selecting a single element from Momentum using iloc and one of the row and column combinations. Boolean selection in Pandas DataFrames in series uses loc. The dimension of the array used to select must exactly match the number of elements in the axis being selected. NumPy accepts Boolean arrays in place of integer indices and treats them as such. Care is needed when using Boolean selection or list selection in more than one axis, and it's usually the case that you need to use np.ix.